Okay, so welcome back. We're going to jump into dividing fractions now. So the rule for dividing is going to have a little bit of a taste of what we did for multiplying, but there's a subtle twist to it. So let's take a look. To divide two fractions, flip the second fraction, which the fancy way of saying that is find the reciprocal of the second fraction and then multiply. So if you just flip the top and bottom, all you're doing is finding the reciprocal. That's the fancy name. So we have our first fraction divided by our second one. The first fraction doesn't change. That's important. The division changes to a multiplication, but then the second fraction you see flip-flops. So we got it upside down now. But once you've done that, now it's a multiplication problem, so you do the same thing we did before, which is multiply straight across. So you multiply the tops, you multiply the bottoms, and reduce it. So let's try a few. Now, if you're looking and you say, oh, wait a minute, 6 and 8, I can reduce that down, don't do it. Don't reduce it down because it's not multiplication yet. The only time you can cross cancel is when it's multiplication. So only cross cancel when multiplying. So don't cross cancel any other time. So the first thing you got to do is switch and flip. That's the kind of the short way to say it. Switch and flip. So we got 6 over 14 times, so there's our switch, and then we got to flip the second fraction to 8 over 3. Now we can cross cancel. So the 6 cancels with the 3, goes in twice. 8 and 14 have a common factor. What goes into both of those? Yeah, only 2. 2 does. So that reduces to a 4. The 14 reduces down to a 7. So now when we multiply straight across, we got 8 on the top and 7 times 1, which is 7. Done. Okay, let's do it again. Don't be tempted to cancel. Got to switch and flip first. So 4 over 3. Now we can cancel. And so we end up with, because one of the fractions is negative, I know it's hard to see, but it is negative. Looks like we're going to get a negative 1/9. All right. Well, we got a couple more on this page. So what about this one? How do we tackle it if it's a whole number or an integer times a fraction or a dividing? We got to put it over 1, same as we did before. So 15 over 1 doesn't change. And then we flip that second fraction. Now we can cross cancel. So what do we end up with? Well, 5 times 7 is 35. 1 times 1 is 1. But we don't want to leave it that way. Anytime we have a 1 in the bottom, we should just get rid of it and rewrite it as a whole number or an integer. So 35. All right, let's keep going. Same as before, or over on this problem, we got to put a 1 underneath 32. So now the 8 over 11 is first, so we don't touch it. But we should get a 1 over 32 for the second one. Do a little cross canceling. Looks like 1 on the top. And 44 on the bottom. Not too bad, right? Just a little bit of an extra step to it. Let's see where we can trip you up. How about letters? Haha. So don't even worry about any cancellation until you switch and flip. So 8x to the 6th power, 15, 5 over 16x to the 2nd. Now, if you're starting to get the hang of how the letters work and the exponents, then you don't need to write it all out, only if it helps you. But if we think about it for a minute, we got x to the 6th power. So that means there's 6 x's all lined up. Over here, though, we got 2 x's. So if we're going to cancel, 2 of the x's should be able to cancel out. So all of them are going to disappear down here. But we're going to end up with 4 left after we cancel those 2 6's out. Or those 2 x's out, excuse me. All right, so there's the letters are done. Now we can look at our numbers. So 5 and 15, 1 and a 3, 8 and 16 comes a 1 and a 2. So when all is said and done, what do you have left? It gets a little confusing with all those crossouts, so be careful. All we have left for numbers are the ones, but we still have this x to the 4th power. Now remember, if there's a 1 in front, we don't need to write it. On the bottom, though, it's just a 3 and the 2, so that's going to be a 6. All right. Almost done. 7x to the 4th over 12 times 36x to the 2nd over 28. Well, we got that same problem we had with the multiplication from before. All the x's are on top. We can't cancel those. They can only cancel if it's diagonal or one on top of the other. But nothing we can do with the x's here. So let's jump to the numbers. 7 and 28 goes down to a 1 and a 4. 12 and 36. 12 goes into 36 3 times. All right, so then what are we left with? So we got x to the 4th, we got an x to the 2nd, so how many x's altogether? We got 6, yep. And there's this 3 times the 1. So it should be 3x to the 6 all over, wow, I'm getting a little bit of a glare there. There it is, 3x to the 6 over 4. All right. There it is, 3x to the 6 over 4. All right, let's try these last two and then we'll cut this video off. Ugh, word problems. Ugh. Well, again, we just got to be a little careful. How many 1/8 ounce eye drop dispensers can be filled from a container that holds 10 ounces of eye drops? Well, you have a few options that you can choose from. The first thing I would try to determine is, are we multiplying or are we dividing? Do we want to see how those two combine to give you a result, or are we seeing how many times something goes into something else? Well, it turns out this is going to be a division one. So you see the word of here, but again, that's deceiving. It's not really an of a quantity or anything like that. It's just of eye drop. So it's not multiplication. So you have a choice now. If we know it's division, we can either write it like this, or we can write it like this. Now, because this is a word problem, it's going to make sense one way and probably not make so much sense the other way. So let's do them both ways and see what happens. So we got our division. Now if we put this 10 over 1, we can do our switch and flip. But now we get 1 over 80. So 1 over 80 is going to be the number of eye drop dispensers that we can fill up. Does that make sense? I don't think so, right? How could you have a fraction of a dispenser that you're filling up? What happens if we go the other way? 10 over 1 times 8 over 1 gives you 80 over 1, or 80 eye drop dispensers. That makes a little bit more sense, because you don't want a fraction of an dry drop dispenser. So again, you got 10 ounces, you got a cup of liquid, and you're trying to pour them in to these little tiny dispensers. You're starting to fill them up. I'm going to keep filling them up, filling them up, filling them up. You're going to fill up 80 of them over time. So 80 eye drop dispensers does make sense. Let's try one more, and that will wrap up this section. Pam Trislia has a small pickup truck that that can carry 2/3 a cord of firewood. Find the number of trips needed to deliver 6 cords. Well, again, a common thought is that we're going to be multiplying, but let's see what happens. If we said 6 times 2/3, well, we can put the 6 over 1. We can do a little cross canceling, and we get 4 over 1, which is 4. So find the number of trips. So 4 trips. Seems like a nice answer, right? 4 trips. Well, think about that. If you're delivering 6 cords of wood and you can't even carry 1 cord in the back of your truck, how is it only going to take 4 trips? Aren't you going to need at least 6 trips? If you're carrying 1 cord of wood and you're delivering 6 cords, that's 6 trips automatically. So you've got to be doing more trips than 4. So something's fishy with that. Let's try division instead. How about 6 divided by 2/3? If we do 6 over 1 times 3 over 2, do a little cross canceling. 3 times 3 is 9 over 1, which is 9 trips. So 9 trips does make a little bit more sense. Just because of the nature of the problem. You're not even delivering 1 cord of wood, you're delivering 6 cords, so that's a minimum of 6 trips. So 9 trips will get all that wood delivered. So with these word problems, you gotta just try a couple of ways and see which one makes the most sense. It takes time and practice before you can get the hang of them. So that wraps us up, and we will see you for 4.4 in the next videos. Stay tuned.